Hey there, and welcome. Have you ever been writing Java and just felt like, man, this is a lot of code for a really simple one-off task? Well, today we're going to dive into a super powerful trick that brings together two big ideas, abstract classes and anonymous inner classes. Now, I know it sounds a little complicated, but trust me, once you get the hang of this shortcut, your code is going to be so much cleaner and way more efficient. So here's our game plan. First up, we're going to lay down the law, the one single unbreakable rule of abstract classes. Then we'll walk through the traditional, the by-the-book way to handle them. After that, I'm going to show you a much cooler, way more elegant shortcut. We'll even peek under the hood to see the magic that makes it all work. And of course, we'll wrap it up with a quick recap to make sure you're totally prepped for any exam or interview question that comes your way. Okay, let's get into it. Section 1, the abstract class rule. I want you to think of this as the one law in Java you just can't get around. It's the foundation for everything, and I mean everything we're going to talk about next. So let's just get right to the heart of it. Let's ask the big question. Can you actually create an object from an abstract class in Java? Can you just type new and make one happen? And the answer is a big fat no. You absolutely cannot. And look, this isn't just Java trying to be difficult. There's a really solid logical reason for this rule. Here's the best way to think about it. An abstract class is like an unfinished blueprint for a house. It might show you where the walls are, maybe the roof, but the details for the plumbing and the electrical systems, they're just outlines. They're mentioned, but not actually designed. You obviously can't build a real working house from that blueprint, right? And it's the exact same idea in Java. You can't create a working object from an incomplete class, because it just wouldn't know what to do. Okay, so if we can't create an object directly from our incomplete blueprint, what's the workaround? Well, that brings us right to section 2, the textbook method. This is the way you'll see it done in pretty much every programming course out there. The traditional way, well, it's a bit of a journey. Let's say you've got your abstract class. We'll call it A. To actually use it, you have to first create a totally new class. Let's call it B. And that new class has to inherit from A. Then, inside class B, it's your job to fill in all the missing pieces. You have to write the code for all of A's abstract methods. And only then, after all that setup, can you finally create an object of your new class B. And look, this method works. It's solid, it's reliable, but doesn't it feel like a lot? I mean, what if you only need that object just one time? Creating a whole new file, a completely new class definition, just for one little thing? Come on, there has to be a better way, right? Oh, there is. And that brings us to the fun part. Section 3, anonymous classes. This is where things get really, really cool. This is the absolute key question right here. What if the entire reason you're doing all that work, creating a brand new class file, is just to make a single object that you're only going to use one time and then throw away? Okay, just look at this comparison. On the left, you've got the old way, a whole separate class definition for B just to make one object. But look at the right. We're doing the exact same thing, all in one go. We're declaring the object and defining its unique behavior right there, on the spot. No extra files, no extra class names, just clean, to-the-point code. You get the exact same result with way less work. And we're not just saving a few keystrokes here. We're keeping our project organized. We're avoiding all that unnecessary clutter that comes from having tons of tiny files. And in the long run, that is a huge win. But hold on a second. Didn't we just say like 5 minutes ago that you can't create an object of an abstract class? It really looks like we just did. Well, not exactly. So now in section 4, we're going to pull back the curtain and see what's really going on behind the scenes. So here's the secret. You are not actually creating an object of the abstract class. What you're really doing is creating an object of an anonymous inner class. That's a class that literally has no name. Java creates this secret one-time use class for you in the background. This nameless class automatically extends your abstract class and includes the method implementation you just provided. So you see, you're still following the rules, just in a really clever and efficient way. And hey, this awesome trick isn't just for simple classes with one method. If your abstract class has 2, 3, 10 abstract methods, it works just the same. You just have to provide an implementation for all of them, one after another, right there inside those curly braces. And here's a little pro tip for you. Most modern IDEs, like IntelliJ or Eclipse, are smart enough to do the heavy lifting for you. They can actually generate all those method outlines for you automatically. Pretty cool, huh? All right, let's bring it all home and wrap this up with a super quick recap. This is the stuff you'll definitely want to lock into your brain for your next exam or that big coding interview. I want you to think of this table as your decision-making guide. It's simple. If you need a reusable component, something you know you're going to create objects of over and over again in your code, then stick with the standard subclassing method. It makes sense. But if you just need a quick one-and-done solution for a single use case, the anonymous inner class is your absolute best friend. It's all about choosing the right tool for the job. So let's nail down the highlights one last time. First, the number one rule: you can never, ever instantiate an abstract class directly, period. Second, the standard solution is to create a separate named subclass. Third, the slick shortcut for one-time use is the anonymous inner class. And fourth, and this is the one everybody gets confused about, so listen up, with the shortcut, you are creating an object of this secret nameless class, not the abstract parent class. And there you have it, a really powerful tool to make your Java code cleaner, more readable, and just more professional. So my challenge to you is this: go back and look at your own projects. I guarantee you can find a place where you can replace a bulky, old-school subclass with a sleek, elegant, anonymous inner class. You'll be amazed at how much it cleans things up. Thanks so much for joining me, and happy coding.